All right, welcome back. How are y'all doing? Thumbs up. All right. So, as has been announced, and I'm reminding you, okay, because no one's gonna act surprised tomorrow. Quiz tomorrow, right? Over vocab, notation, and some solving stuff we've been doing. So, no surprises tomorrow, right? We all know this. Uh, Make sure you're turning stuff in. All the first goal setting, one step, two step, multi step are all in the grade book. Check those out if you haven't turned them in. They're hurting your grade. Check Skyward. If you need to correct something, if you didn't grab stuff on the way in, make sure you do that. Notation will be going in soon. Let's talk about notation on this warm up. I need to name two different rays. Now, all I see here are four lines, but within lines are rays. So, can someone tell me two letters that connect to make a ray on here? Anybody? B. B towards which way? Okay, so what letter does it go towards? B A. Okay, so if I started at B and I go towards A, that is a ray. So I would call that BA with a ray. You always put the end point first and then the direction it's going second. What's another ray somewhere else? So maybe up here. Is there a ray up here I can use? D towards C works, yeah. My drawing is really bad, but D towards C is a ray. It's a different ray. So BA is a ray. There's actually 12 different rays here you could make, if you can imagine. Okay? All right. All right. Now, that's it. We're just doing two right there. Now let's name a pair of opposite rays. Now y'all know opposite rays are going opposite directions, right? Right? You don't got headphones, do you? Oh, I can't see. That's why. All right. Well, anyways, opposite. They're literally going so opposite they look like a straight line. So do y'all see two rays that are going opposite directions? Like a point on the line, and then it goes one way and another way. So C is in the middle of this line, and it's going to the right and the left, right? So what do you call this one going to the right? CB, I heard, is correct. And then opposite means it's going the other way. Which one's that? CA. Those are opposite rays going opposite ways. Say what? It is, but the notation is always going to the right. Start with the endpoint, notation goes right. Now, the last question is if we have three lines that cross C. So here's C. I can see one diagonal, two diagonal, and one horizontal, three lines going through it. I just have to name the lines. So I heard EC. Those are 2 points that make a line. You just got to put the line symbol on top. Okay? That looks horrible. Let's try it again. Okay, so EC, that's one line. What's another line? DC also goes through point C. Those are my two diagonals. And then horizontally, what's the name of this line? AC or AB, either way, it's the same thing as long as you have 2 points on that line. Okay. Well, that's it for the warm up. We do have some notes on segment addition. I'll pass them back over. All right. Today is the 21st. Okay. Make sure y'all pass those papers back. Yeah, all three. Thank you. All right, here we go. Segment addition postulate. All right, first thing you got to know, the word between. Do y'all know what between means? Kind of, right? I mean, you do, I'm sure. But in math, this is what it means. Okay, between means uh, a point can be between when all 3 points are collinear. Okay, so here's an example. Do you see how this point B is in between A and C because it's on the line? That's between. Over here, E is not on the line. That is not between. Okay, see the difference? Pretty basic. Just want to make sure we know that. Between is on the line. Next thing we got to know is congruent. Line segments that have the same length are congruent segments. We talked about it on the notes on Monday. Same size, same shape, same measurement. Okay. So you can say it this way. AB is equal to CD. That's the measurement. Or segment AB is congruent to segment CD. Okay. So this symbol right here, do y'all see this with your eyes? This is a congruent symbol. That means is congruent to, which is the same size and same shape. Okay. Here's some examples. How do I know this segment and this segment are congruent? Do y'all remember this little marking right here? I call it a tick mark. Tick marks notate that it's congruent segments, same size, same shape. Cool. So again, how do you say it? You can either say AB is equal to CD, or segment AB is congruent to segment CD. Well, let's talk about segment addition postulate. Ready? If you have 3 points, A, B, C, and they are all collinear, write that down, collinear. If you got 3 collinear points and B is between, right, A and C, then here's our postulate for today. The left part, AB, plus the right part, BC, is equal to the whole thing, AC. Okay? For all created things, this is a general truth that we know, that parts add up to equal the whole. Okay? And I do want you to write this down. This is the essence of our notes today. Okay? Whenever we have a segment that's broken into parts, you must know that the part on the left plus the part on the right equals the whole thing. Okay, do we understand that? Part plus part equals whole. Let me give you an example. Y'all ever ate a whole pizza by yourself? Or shared a pizza maybe? But obviously pizzas have slices. Those are the parts. And all those slices add up to the whole pie, right? We know conceptually that the parts add up to the whole. So all we're going to do is apply that to this segment situation. So I was asked earlier, when are we talking about shapes? Well, here we go. First things first, segments, right? Now y'all see this picture. We have a segment, 3 collinear points. F is like somewhere in between E and G, right? So those are 2 things we want to like mentally check mark. E, F, and G are collinear, check. F is between, check. Okay. If that's the case, well, now I have part, and then I have a whole thing. So when I'm looking at this image, I see the left part is 8x minus 17. Can y'all put parentheses around that? The right part is 5x minus 3. You can put parentheses around that. But here's what I don't know. What is the whole thing from E to G? I don't see it over here in the picture, right? But I'm telling you, you gotta read it. If you read starting right here, it says, if EG equals 71, now we can find X. So hear me say this. You must label your diagram, okay? So if EG all the way across is 71, I want you to label it. Watch me do it. I'm going to put a big old bracket. From E all the way to G is 71. So make sure you write that down right there. Label the whole thing is 71, okay? So to do a problem like this, okay, we're going to use this idea that part plus sign part equals sign whole, okay? Here's what I don't want you to do before we set this up, okay? Some people look at a problem like this, they either give up too easy or they kind of aren't thinking too much. But I want you to notice EF and FG, the two parts, we don't know if they're equal, right? So you don't always just want to set everything equal to each other. So we don't know if F is a midpoint. We don't know if it's bisected. We just don't know. Even if it kind of looks like it, we're not going to assume. So here's what we're going to do. Part plus part equals whole. So what is the left part? 8x minus 17. So go and start writing your equation here. 8x minus 17. That's the left part. Then plus, make sure you're writing this down, everybody. Plus, then the right part, 5x minus 3. Those two parts have to add up and equal the whole thing that we had to label from E to G, which is 71. Half the battle is setting up the equation. So I want you to take a look at this, pause and ask yourself, do I know how I set this up? Left part plus right part equals whole thing. Sometimes the whole thing is in the words at the top, okay? Now, here's the next half of the problem. You got to solve it. Now, y'all feel, by show of thumbs, y'all feel like you could solve that just like right now? Easy. I'm not feeling any thumbs. How do y'all feel about solving that? I'm not asking you to say words. Show me your dang thumb. Okay. Mid, up, mid, that's fine. So if you are not feeling 100%, now's the time to lock in, right? I'm gonna show you. It's not gonna be that hard, I promise. First things first, we did a warm-up, I think earlier this week, on how to solve when there's more than one x on the same side, okay? So look, 8x and 5x, they're both to the left of the equal sign, so you're going to combine like terms. Combine them, add them together. What is 8x plus 5x? 8 plus 5 is 13x. Now, if you didn't know that, you're allowed to use Desmos, okay? Notice also we have a regular number and a regular number. These are constants. You can combine those as like terms too. Negative 17 and minus 3. Don't forget the sign. Negative 17 and... One second. Sorry. Where are we at? Here we are. Okay. Reminder, you're allowed to use Desmos, so negative 17 minus 3, if you need to. Don't forget the negative goes with the number, okay? So negative 20 is what we get. Bring down equals 71, okay? So look, let's recap. What have I done so far? Part plus part equals whole. And it's going to look too complicated. So how do you make it less complicated? Combine like terms that are on the same side, okay? Now, once it's at this point, you should be able to do a two-step equation, which is what we did last week, right? I know some of us still need to work on that. You got all year long, you will have to solve for x. It will not go away. You got to get good at it. Practice, practice, practice. So here's more practice. If I'm trying to get x by itself, what do I get rid of first? The 13 or the minus 20? The loner is minus 20. The opposite is plus 20, plus 20. 71 plus 20 is 91. Okay, so is everyone with me? Looking over here. We got rid of the loner. Last step, we know 13 in x. There's an invisible multiplier there. How do I get rid of 13 in front of x? Divide by 13. 91 divided by 13 is 7. You can use Desmos or mental math, but that is how you do a segment addition problem in which you know two parts and the whole, okay? So it'll be different if you know something's congruent. But at least this type of problem, this is how you do it. Part plus part equals whole. Okay? All right, next one. Y'all ready for example 2? Now, what do we see here? We have a part, a big part, we have a little part, but I don't know the whole thing, TV, from this picture. But if I look right here, doesn't it tell me what TV is? TV is 14x minus 8. So let's go ahead and label that. Everyone do this with me. Put a bracket for the whole thing. That is 14x minus 8. Okay? How do I set up my equation? Part plus part equals whole. The left part from t to u is 9x plus 2. Plus the right part. Now look, the right part is this little piece. If all that's labeled is 5, you got to just put 5. That's it, okay? And that equals all the way across from t to v, which we know is 14x minus 8. Part plus part equals whole. All right, y'all ready? Now, this one's a little bit different than last time because this time the x's are not on the same side. Do y'all see how this x is on the left of the equals, this is on the right? That reminds me of this assignment, multi-step. When x is on different sides, I need to get rid of the smaller x, okay? Which x do I get rid of? Which one's smaller, 9 or 14? 9. How do I get rid of a positive 9x? Subtract. Actually, hold on. My bad. Before we do that, can we combine any like terms?
No.
So the x's are not on the same side, but look right here. Regular old numbers, those constants, you do want to combine those first. It'll make life a little easier, okay? A regular 2 and a regular plus 5 add up to make what? 7. So bring down 9x plus 7 equals 14x minus 8, okay? Now, like we said earlier, which x do I get rid of since they're on both sides? The smaller x is 9x. Let's subtract 9x from both sides. Bring down 7. 14 minus 9 is 5. Bring down minus 8.
Plus 8. Plus 9.
Yeah, so now we got to get rid of that loner. So yeah, it's minus 8. To get rid of minus 8, we do plus 8, the opposite. You're right. And then 7 plus 8 is 15. Last step to get rid of a 5 in front of x. We do divide. So x equals 15 divided by 5 is 3. Okay. Now, are we done? It looks like it, but we're not because it has another blank. It says, what is TU? So look on the picture. Y'all see between T and U is this expression? So TU is 9x plus 2. And so what? Well, don't I know that x is 3, right? So I'm going to replace x with what it equals, 3. This is called substitution or evaluation. 9 parentheses 3 plus 2, which means 9 times 3 plus 2. 27 plus 2 is 29. Okay? You should be able to take your x, plug it back in, and get your solution. Okay? So, what we're going to do, I have a practice for you. It is two-sided, but if you do the first 4 on the front side, that's good enough. Okay? The back is an extension. for further practice, but the front side is what I need. So 1 through 4, cool?
Yeah.
The only difference you might find on at least one of these is you need to label it yourself. Okay, so if you get stuck, let us know. Use your notes. These examples will really help you. I promise, okay?